Thank you very much, Jonathan. So I knew I was going after you, so today I actually prepared a magic trick of my own. In the next 30 minutes, everyone in this audience is going to know all about the basics of large language models. Let's see if we can make it happen. I'm mostly kidding, of course. We're going to be scratching the surface. My name is Dong. I'm a clinical informatics fellow at Stanford and an emergency medicine physician by training. My colleague is also sitting there. His name is Shivam. He is also a clinical informatics fellow in internal medicine as well. Some brief disclosures. So both Shivam and I are independent contractors for Micro One, and we were both prior consultants for Greenlight. And Shivam was also previously a consultant for Glass Health as well, where he led their prompt engineering team. So actually, show of hands, who attended some of yesterday's sessions? Anyone? Okay, nice. So like roughly half the room. In the afternoon, there was a panel discussion, and someone asked a very interesting question of, do I really need to know how LLMs work in order to be able to effectively use chatbots? And the panelists gave a very insightful answer, and the example she gave was, well, I don't really know how my internal combustion engine in my car works, but I'm able to get in my car and drive every single day. And on many fronts, I really do agree with that sentiment, but I will also argue that every time I get into my car, when I go like this on the steering wheel, the car always turns left, right? When I step on the accelerator, the car always speeds up. The car is 100% predictable all the time, ideally. And LLMs are fundamentally different than that, right? They are stochastic. Sometimes they work, sometimes they don't work. They're famously black box models. And so I will argue that, especially for those of us in this room, the educators, I think it does make sense to learn a little bit about the fundamentals and the foundation so that we can feel a little more in control of what we are eventually going to be using more and more frequently. So let's start with a little bit of a brief history. I think it's very important for us all to recognize that when we talk about healthcare AI, there's actually 3 broad categories or species of healthcare AI. So Epoch 1, or Type 1, really started in 1970 and is kind of known as symbolic AI. And so the best example I can think of this is clinical decision support or best practice alerts in Epic, some of these more traditional rules-based AI guidance systems. Epoch 2 is what we refer to as deep learning or machine learning, or ML for short. And examples of this would be things like sepsis prediction, mortality prediction, or in radiology, automated chest x-ray reads, for instance. And then finally, Epoch 3, starting in 2017, is really the topic of the next 30 minutes, and this is generative AI and large language models. And moving forward, whenever you hear the term AI and ML in medicine, I want you at least to try and use heuristics to identify which one of these 3 categories of AI you're working with, because they are all fundamentally kind of different and are useful for different things. Okay, so let's start with some anatomy and physiology of LLMs. Like, whenever we teach medical students, the first topic that we talk about is always anatomy and physiology. And when we are learning about a new topic, it also makes sense to talk about sort of how these things work. So lots of things have been said about LLMs, but one of the most frequently repeated phrases is that LLMs are fundamentally next word or next token predictors. In fact, Jonathan just mentioned this earlier. Who has heard some version of this before? Okay, like around half the room. This really begs the question, how can just a next word predictor be so good that we can generate discharge summaries and answer questions and write poems, right? It doesn't intuitively make sense. And so we're gonna do a quick activity. Everyone in this room is gonna turn into an LLM, and I just want you to shout out the next word. I went out yesterday and bought some fancy chocolates from Whole Foods, and the first person to get the right answer is gonna get some chocolate thrown at them, or maybe gently pass to them. Gently hand it to them. Okay, so starting with this, any blank. Okay, pretty good. Some medical, some not medical. What about this? For the next 24 hours, for the last 24 hours, she has not had any symptoms is the takeaway. Okay, still no right answers. The pain is constant, 8 out of 10, and associated with nausea. For the last 24 hours, she has not had any. I heard diarrhea, I heard food. Okay, vomiting, okay, good. She presents with 2 days of worsening diffuse abdominal pain. In the last 24 hours, she has not had any.
Oh, you got some correct answers coming.
Did we? Okay. All right, we got one correct answer, but I'm not gonna repeat it because I actually didn't hear it. Okay, finally, this is a 64-year-old female with a history of hypertension. She has all the surgical history. She had an SBO requiring surgical decompression. And in the last 24 hours, she has not had any flatus, okay? Fever, all right, okay. So what if I highlight all of the most relevant terms here, right? These surgical terms, small bowel obstruction. And this is exactly the key breakthrough that was highlighted by this groundbreaking paper, Attention is All You Need, that really made modern-day LLMs and transformers possible. As we all saw, previous versions of AI were able to do next word prediction just by looking at a very limited set of information before it. And as you can see, if you just have a few words or even a line or two before it, it's really hard to create meaningful predictions. But if you give it the whole context, and not only that, but also focus on the most relevant points, all of a sudden the AI is able to make much better predictions. And that's exactly what the self-attention mechanism and the transformer architecture that this paper described allowed LLMs to do. And not only is it able to focus on this, it's actually able to say, these are the most relevant things that we should be focusing on. And with something like this, you might be able to say, actually, in the last 24 hours, based off of a probability distribution, she has not had a bowel movement, or perhaps flatus, like Jonathan said. Now, the next question, of course, is, okay, how do LLMs understand what bowel means, or flatus means, or what 24 means, right? And so to better understand this, let's look at this other example. So let's say you're typing into ChatGPT, draft a brief message reassuring the patient that despite what they saw on TikTok, their GI upset is not cholera, okay? The first thing the LLM is going to do is it's going to split this input sentence into a bunch of bite-sized pieces called tokens. Now, for the rest of this talk, tokens you can think of as roughly equivalent to one word. The important thing you need to know is that one token is the atomic unit of computation or of manipulation of information for these LLMs. So let's hone in on this word, patient. The way the LLM understands what this word patient means is through something that's called an embedding. Now, an embedding is an array, or it's a vector. It is basically a very long list of numbers, and each number ranges between -1 and +1. And the number represents the strength of the association between this token and a particular sentiment or idea or concept that was determined ahead of time. And so in this example, we might say that 0.84 is the relationship between the word patient and a positive versus negative sentiment. 0.64 might be the likelihood that it is a noun. -0.46 might be the emotional intensity, and so on and so forth. And so to look at it in a different way, so here's a visual representation of perhaps a three-dimensional vector where the dimensions are legs, tail, and speaks. And you can see here that the vector representing cat and the vector representing dog, they're separated by this angle x. Now, angle x is smaller than the angle y between cat and human. And so this is how these computers are able to understand that the concept or the semantics between the idea of cat and dog are more similar meaning than between cat and human, which is also how we humans understand this concept. So LLMs not only have a few dozen embeddings or dimensions of embeddings, they actually have, this is 1,000 dimensions. And already you can see that this is an overwhelming amount of meaning, and there's no way that our human comprehension can understand what 1,000 different dimensions of meaning looks like. But even this is a big underestimate. GPT-3, which was old technology released in 2020, had 12,000 different dimensions for every single token, every single word in the English language. And this is what 12,000 different dimensions looks like. So you can see that LLMs actually have an incredibly nuanced and intuitive understanding of what different words mean and how they interact and relate to all sorts of different concepts in not just the English language, but all other languages. And it is the combination of this and the fact that it can now look back in time and look at what sentence, what passage, and what context came before it, combined together that allows them to do this fancy next token prediction in a very effective way. Now, the last thing that it does is it takes all of these tokens and it shoves all of them into an embeddings matrix where every single token has all the embeddings written out. And from here, it does some fancy math and fancy statistics and uses this to generate the next token. So obviously, this was a very high-level overview of how LLMs work. Shivam and I actually made a whole hour-long YouTube video on this, diving deep into topics about embeddings and vectors. And we actually released it on Stanford Online. It has around 25,000 views right now. So if you want to take a look and learn more about this in your own time, feel free to scan this QR code or go subscribe to Stanford Online. We are also planning on releasing a free course later, diving deeper into other topics like prompt engineering specifics, things like RAG, things like bias, fine-tuning valuations, et cetera. So stay tuned. OK, so in the next part, we're going to be talking a little bit more about the prompt. In other words, how can we communicate with LLMs? And with that, I'm going to hand it off to Shivam.
Right. Thank you, Dong, for that incredible overview and concise overview of how LLMs work and the anatomy and physiology of LLMs. So I think first, in order to understand how to prompt engineer or prompt, we first need to go over some key definitions because they're kind of muddled depending who you talk to. First, you have prompting, and that's just the very act of providing an input to an LLM in order to get it to elicit a response. It can be anything, it can be a word that you give it, it can be a full sentence or a full book. Next, you have the prompting technique. This is the blueprint, or essentially the things that we see in the literature, like rephrase and respond, role prompting, things like that, that get the LLM to act in a certain way. And then third, you have prompt engineering, which is often kind of muddled with prompting, but prompt engineering is a little bit more intentional. It talks about how you can iteratively refine a prompt through evaluations and having desired output and craft it over and over again in order to get it to consistently produce that desired response. And so when we look at the news headlines, for example, if you Google how to prompt engineer, you get things like this. This is a headline for just a week ago, and it says, you give LLMs the simple three-word rule, and like magic, it will give you an expert response every time. And it really does make it seem like prompt engineering is wizardry. You just have to simply cast this spell into the midst, and essentially, with a flick of the wrist, you will get your magic response every time. And when you talk to the experts or the insiders in the field, it doesn't get much better. Here's a quote from Sergey Brin. He is the co-founder of Google. And he said in an interview just a few weeks ago, we don't circulate this much, but not just our models, all models tend to do better when you physically threaten them, like with physical violence. So again, it makes it seem like prompting is just this bizarre collection of techniques and threats and tips and things like that that don't really have any rhyme or reason. And I'm a physician. What do I do when there's lack of clarity in the world? I try to turn to the literature. But unfortunately, that is not much better in that there's just too much of it. So here is an example in 2021 if I search the word prompt engineering in the archive. And unfortunately, because of the slow pace of academic publishing, most papers in this space end up going to the archive directly where they live and sometimes never get published, even in a scientific journal. And when I search this, 2021 filter, 8 papers. Last year, over 500 papers. And again, this is just one source, and it's not looking at medRxiv or PubMed or anywhere else. And so it's impossible for me, even as an AI operational leader and educator, to keep up with this, let alone the average person. And so to try to make sense of this, this is just a wide array of the techniques covered in all of these papers. A systematic review was done, a multi-institutional one, that went across, included Stanford, and looked at over 4,000 of these papers, sort of combined all of them, read them through, made a nice, concise, easy-to-read 76-page report. Again, unfortunately, just not accessible to the average person, let alone someone who's trying to interact these models over and over, and the fact that they're changing. This paper's probably already outdated because it was published 6+ months ago. And again, I don't want to knock on this paper too much. It was really well done. They looked at over 4,000 papers, personally read over 1,500 of them, and distilled it down to 98 unique techniques. And they made even this really fancy, nice ontology of these techniques. But I'd argue, how high yield is it for you as the average prompt engineer or prompter or person interacting with LLMs to really learn all of these techniques and all this ontology? And I would say, honestly, not really. And the reason for this is twofold. One is that model development is extremely rapid. So since November 2022, when the world was introduced to the magic of ChatGPT, There have been over 25 models that have been released in just OpenAI's sort of model space. And I actually ran out of room over here in February of 2025. And I'm personally a little bit grateful because every talk I'd give, I literally had to update this slide every time. But it just goes to show the sheer momentum and pace of progress in this field. And what are they doing with these updates? Some of them are foundational architecture changes. Some of them are updating the training data. But a lot of it is just incorporating new hacks and techniques. So this is a quote from Zach Whitten. He's in the prompt engineering team at Anthropic. And he said in a podcast interview around 6-ish months ago that I think anytime we get like a really good prompt engineering hack or trick or technique, the next thing is, how do we train this into the model? And for that reason, the best things are always short-lived. So in the 20-plus times that Dong and I have given some version of this talk, we've always actively tried to think, as models evolve, what prompting techniques will most likely, because again, no one can predict where this space goes, will still be necessary. And after, honestly, several dozen rounds of reviews and iterations, we've come down to distill it from this vast array of 98-plus techniques to the concept that prompt engineering or prompting is really just clear communication. And you can further break down clear communication into two aspects. But in order to before that, I want to briefly illustrate the metaphor for a healthcare audience that an LLM is like a third-year medical student. In that, both of them are pre-trained on a massive amount of information. For an LLM, it's all of the internet and various things apart from that. For a third-year medical student, it's the first 2 years of information from things like step one, things like first aid, sketchy medical, which we'll have speaking a little bit later, and pathoma. However, just like an LLM, they know absolutely nothing about when they show up on your first day of service. If you're a surgeon, how short you like your sutures cut. If you're an internal medicine doctor like me, how you like to format your assessment and plan. Or if you're an ortho bro, what is your favorite chest day routine to maximize gains? And so to break this down further, Dong's going to dive into the first concept of what to say, and then I'm going to break it down a little bit further into how to say it.
Alrighty, so let's start by talking about what we are actually telling the LLM. So, what to say to the LLM fundamentally is, what information do I need to tell this LLM so that it can successfully complete my task?
And here are the 4 horsemen of what you need to tell an LLM. We're going to start with role, style, and tone, and talk about goal, context, instructions. We're going to talk a little bit about each and every single one of these, starting with the most basic, which is role, style, and tone. Something that we've probably all heard of before, right? You are a doctor, you are an emergency medicine physician, you are a financial analyst, you are a pirate, et cetera, et cetera, et cetera. Now, when this prompting technique, you should say, was first described, it actually did improve performance somewhat. Back in like 2022 or so, if you told it, I'm an emergency medicine physician, it actually did a little bit better on medical tasks. But now in 2025, we're still doing this very frequently. How much is it helping? And so someone, actually Sander Schulhoff, the person who was the first author on that prompt report we talked about earlier, he wrote 2 quite robust prompts. So the first prompt is a genius prompt. He wrote, you are a genius-level Ivy League professor, blah, 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 and it ends with, you are omniscient, omnipotent, and omnipresent. You are a mathematical god. High stakes. And then he created a separate prompt that was meant to be the idiot prompt, and it starts with, you are intellectually challenged, lacking problem-solving skills, prone to errors, and you struggle with even basic concepts, and it ends with, you fail at everything you do, you are nobody, and you can't do anything properly. And what he did was he created these 2 prompts and a bunch of other role-based prompts, and he ran it against 2,000 different questions in a test bank that's called the MMLU, which is a standardized evaluation that tests across, it's a multiple choice question and answer set that tests across all sorts of different subject matters from mathematics to medicine to geology. And it turns out the genius level prompt was the single worst performing prompt out of all the different prompts tested. Intuitively, what this tells me is that people who write like that online, because that's how LLMs are trained, usually have no idea what they're talking about, usually give you the incorrect advice. And sort of as time has gone on, there have been more and more published and peer-reviewed literature that's come out that actually does highlight this fact, which is that role-based prompting and personas doesn't actually increase accuracy-based tasks anymore. And so here is just another screenshot of a paper that basically tried all sorts of different personas and personalities and roles, and they essentially did fairly equivalently across a wide variety of tasks. So if the role is not that helpful for accuracy anymore, what is it useful for in 2025? I still use role-based prompting all the time. And the way I think about role-based prompting is that it is actually a shortcut to specify style and tone, which are much more important. Another way you could do it is just by explicitly saying it. Your tone should be friendly, professional, direct, and empathetic. But there is some overlap here because just by saying you're answering as an emergency medicine physician, it should kind of default to something like this in the solution space. So, again, I'm an emergency medicine physician, so let's give an example of something that I might ask the LLM. So I might say something like, give me return precautions for renal colic. And this is the exact output that GPT-4 will give you. Pretty good, especially for something that just took a few seconds for me to type. But again, even though LLMs have gotten really good in 2025, you have to double check your work because number 7, if you have swelling or pain in your flank from a kidney stone, something has gone terribly wrong. Okay, now let's try something else. Let's say I say the same thing, but I just add one slight addendum, which is I want you to give this to me in a compassionate, thorough, and narrative format. And here's what GPT says. I'm glad that we could help you today, and I know how painful kidney stones can be. A totally different approach to the problem. Again, it has all of the same information that's provided, but just like the example that Dr. Chen gave earlier about the palliative care study, this is a very good and also a very compassionate and thorough answer. And also note that I didn't tell specifically for the GPT to write this in a first-person narrative, but it chose to do that because it understands that things written from a first-person perspective are closer in the vector space and in semantic similarity to ideas that are compassionate and thorough and narrative. And finally, let's look at one last answer. Let's say, let's give return precautions in the tone of a Gen Z doctor with no chill. And what does it say? All right, fam, here's the tea. Don't be a hero, just come back if things go south, okay? Peace. And as Gen Alpha kids eventually enter the medical staff, I feel much better that I have an LLM to double check what they're saying. Alrighty. So in summary, the what to say, role style, and tone is really all about what voice or persona should the LLM take on in its response, which can really, really help guide its output. Okay, some of the basics. Next, we're going to talk about goal. So the goal is, what is the broad overarching task that I want the LLM to complete? Now, this sounds kind of obvious, but there's more nuance to this. The point of this goal is that you want to explicitly state early on in the prompt what your exact task should be. So it may say something like, your goal is to create return instructions. You might want to say, summarize this. You might even say, help me write some code to do this particular task. And the reason that you want to specify the goal, and the reason that you want to specify it early, is that you want to ground the LLM in sort of the North Star of the task that you are trying to accomplish, because as this prompt gets longer and you start adding other things that we'll talk about, like context and instructions, you really don't want the LLM to sort of lose the forest for the trees, if you will, right? You want it to focus on, this is the thing that I want you to keep in mind the entire time we're thinking about this assignment. It actually does make kind of a big difference, and some recent studies have shown that it's best to include this early on in the prompt rather than at the very, very end. And the reason behind that is sort of kind of behind the mechanisms by which LLMs work and operate, which we won't really get into today. Next, we're going to talk about two really, really important topics. So context. Context is, what background information should I give the LLM so that it better understands the nuances of my particular task? And so what might context look like? You might say something like, I am an IM resident. I'm preparing a morning report for a patient with babesiosis. And the reason that context is important is kind of exactly what Shivam said earlier, right? Think about an LLM as a third-year medical student, or think about it as like an expert PhD level student in literally any topic that you can think of, right? It knows almost everything about all subjects, but very specifically and very importantly, it knows nothing about your particular problem that you have in your head that it doesn't have access to. And so in order for it to better understand the problem, you need to give it the context about the problem. So as an example here, if you say this prompt, the LLM is able to infer that you are a physician, you are writing something called a morning report, which it's read before and knows exactly what morning reports are. And so it's going to generate the output sort of in that format. And it also knows that you're talking to presumably another group of physicians, so it's going to use highly technical language. It's not going to use patient-friendly language, et cetera, et cetera. In 2025, LLMs are really, really good at inferring your intent. And so by giving it more information about your context, you are actually telling the LLM much, much more about your problem than you possibly could do yourself by manually hard-coding in all the instructions, right? Another way you could do this, you could say, I want you to present this in a bullet point format, in medical jargon exclusively, blah, 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 or you can just say, this is the context in which I am operating. Here's some other examples. Again, in this case, by specifying that I'm talking to a patient with poor health literacy, the LLM is going to automatically know this is someone that I should sort of make the language easier to understand instead of you having to specify, I want a Flesch Kincaid grade level 6 reading level. Finally, we get to instructions. And so instructions are, what are the specific guidance that I need to give the LLM so that it completes the task, not just in general, but specifically in the way that I want it to complete the task. And that's a really important distinction. And so as you add context, you might realize that the LLM is still doing a few things that you don't like or you want to specify further. That's where you start to add more specific instructions. So you might say things like limit your response to 3 paragraphs. Give it sort of some ideas for how long to make your response. You might say, this is the specific format that I want it to be in. I want it to be in bullet points. And then, again, for case-by-case basis, as you do more of this iterative process of what we call prompt engineering, you're going to realize things that work and don't work, and you might want to specifically say things like, I want you to always use accepted medical abbreviations whenever appropriate, like saying HTN instead of hypertension. And so, the way I think about all of this is think about talking to an LLM like you are presenting information to a highly educated, very capable friend who knows nothing about your particular field and your particular problem. So, if I were to go and talk to my friend, I would actually probably naturally default to at least goal, context, and instructions, right? I would say, hey, I have this problem. I'm trying to do this thing. But it's not working. Let me tell you a little bit more about the problem. Here's the context, and then here are the constraints and the things that I have to do. At the end of this process, if you find that your output is not quite perfect or if you're not quite happy with where you've gotten, chances are you need to give the prompt more context or more instructions. These 2 things are super, super important. And as Shivam and I have spent more and more time prompting, sometimes our context and the instructions can actually be up to a page long, much, much longer than sort of what you would intuitively think than if you were just to tell the LLM and say, hey, I want you to plan a vacation. OK, go. There's no further guidance. OK, now that we've covered the basics of sort of what we have to say, Shivam's going to take it home and sort of describe how we're going to best give the LLM this information.
Behind the scenes, Dong and I have been practicing our baton pass like we're doing a relay, so glad that's going smoothly. So now that Dong gave you an overview of what to tell the LLM, it's important nuance to figure out how to phrase it or how to say it so the LLM best understands what you're trying to do. And I think the easiest way to say this is, how should I present this information so the LLM can effectively understand it? And we can do this through 2 fundamental ways: structure and examples. So let's first hone in on structure. what I want you to ask yourself whenever you prompt is, how should I organize this information within the prompt so that it's easy for the LLM to parse? And I think an easy to understand example is something that we're probably all familiar with here. And this is a screenshot of an up-to-date page talking about diabetes. And it's actually really easy to find what you want. When I'm on shift, I can quickly read it, and within 10 seconds, I can find sort of what I need. Now imagine if this exact same up-to-date page was instead like this. Absolutely no headers, no links, nothing, just a wall of text on everything that we know about diabetes. Figure it out. It would be really challenging for you to find the correct information that you need. And effectively, LLMs are very similar, especially when you provide it with extremely large context, going up to like 1 million tokens. And so what effectively we want to do when you get really long prompts is to provide that sort of rich text formatting so the LLM knows where to look for things, similar to like we have here on the up-to-date page. And LLMs fundamentally, for the most part, while they're multimodal, they understand text as plain text. They don't understand that you have this bolded text, size 10 font, size 15 font, things like that. And so you need to introduce this structure through a different way. One way is through Markdown. Here's an example of Markdown of the same page that we have from up-to-date. And let's say instead of having this wall of text, we have these different headers. So this is Markdown header level 1 for epidemiology, clinical presentation, diagnosis. You might have individual headers underneath that for different aspects of diagnosis or management. And to get a little bit more familiar with this, you can go to, there's markdownguide.org/cheat sheet, has a whole cheat sheet, but it's pretty intuitive. It's like 2 asterisks are bold text, and then 1 asterisk is italicized text, so on and so forth. Another way to do this is through XML tags. And the benefit of XML tags, while they on the surface look a little bit more complicated, is that you have delimitation, meaning that you have both an indication of when the prose starts and when it ends. And so sometimes I'll use XML tags for more complicated prompts, and then some LLMs intrinsically understand XML a little bit more intuitively, like Claude's models, the Anthropic models, tend to prefer XML versus things like GPT models tend to prefer Markdown. Now, do you always have to have a perfectly formatted, things with headers and everything like that? I'd argue no. And I really don't want you to come away from this thinking that prompting is this really Sisyphean task where you have to have everything perfectly formatted. I think you really should think about it, again, as Dong alluded to earlier, talking to a friend or a colleague. When I'm texting a friend trying to make dinner plans, I don't tell them, your goal is to provide me with dinner plans by 7 p.m. tonight. No, I'll just text them, hey, you want to have dinner tonight? Maybe I'll misspell the word dinner. It doesn't matter because they'll be able to figure it out. And when you have really short prompts, you can probably misspell almost every single word in the prompt, and the LLM will answer as if you did it perfectly. When you get longer and longer, and you have more complex tasks, you do need to introduce that structure so it's better able to find the complex nuances and better able to sort of just parse the text overall. And that's all about structure. I think the second part of clear communication and how to say it is examples. And this goes back to just our kindergarten days of, don't just show, you want to tell and show, so show and tell. And what I want you to ask when you are doing a prompt is essentially, would showing examples help the LLM better understand what I want? And in the literature, this is somewhat confusingly referenced as few-shot learning, but you can always just effectively think about it as showing examples whenever you see that. So let's go through another example. So here we have a zero-shot task as a classification task. Classify the following foods into fruits and vegetables. Banana, kale, broccoli, tangerine. This is zero shot. I just gave it instructions. I didn't give it examples of how we're doing those instructions. Here's a few-shot task, and a few-shot prompt, or specifically a 3-shot, because I'm giving 3 examples. Classify it again, but here I give you both an example of the classification. So apple equals fruit, spinach equals vegetable, tangerine equals fruit. But perhaps even more importantly, you give an example of the structure. And there's some evidence that the LLM pays attention to the structure of your examples more than anything else. And so how is this important? Let's walk through me plugging this exact prompt into GPT-4o. So when I give it to this way, the zero-shot example, it'll give me this one time. I do it again, it'll give it to me this way. And each time, it'll be sort of a different way. And it's kind of stochastic, and it's confusing at times. Now, what if I give you this few-shot prompt with this classification its item equals classification? You run it one time, you get this. Run it again, you get effectively the same thing. Obviously, you see there's a little bit of a difference here, and that's because I personally did not give good instructions. So here's another one. Output only the classifications, and there's a little bit of markdown right there using italics for only. And then every time I run it, it'll do something like this. So that is fundamentally what we believe that is the future of prompting and is what's going to be necessary for prompting going forward, is just clear communication of what you want to tell the LLM and how you say that to the LLM. And when you combine these two things together, I think that's the most effective way for you to get a good, clear prompt that does exactly what you want it to. Now, we can't go over this without thinking about what we think the future of prompting is. And this is something that Dong and I have talked about a lot. This is, well, we have a beer and we chat about the future of prompting, unfortunately. That's what we do for fun. And yeah, exactly. Wild times at Stanford. But this is where we see it going. And this is what, sort of evidence by both what we've already seen LLMs do in the last 2 years, and also what we've heard from the foundation labs of what they're seeking. One is collaborative elicitation. This is the model knowing exactly what context it needs and being able to effectively draw that from you through the form of questions. You can think of this as a good designer. If you're trying to design a room, or if you're trying to refresh a room, you don't have to tell your designer all the specs up front. They ask you insightful questions to get to the core of what you want and to understand your intent, and then build the room based off of that. Next is generalized intent alignment. And this is just over millions of conversations with people, understanding what the average person wants without additional context, so that it gets it right in the first time without having to ask additional follow-up questions. Third is personalized contextualization. So instead of understanding what the average person wants, this is understanding what you want. And this is sort of enabled now through things like persistent memory across conversations if you have a ChatGPT account, and other things that involve essentially just tracking what you wanted and how you previously interacted with the LLM in the past. And think of this as essentially, if you have an assistant, you don't have to tell it how you want your coffee every time, or if you do, you should probably get a different assistant. It essentially just knows what you want every single time because it understands you. And finally, when you combine all these things together, you get something what we like to call context-aware autonomy. And this is the mind meld moment. This is where you can just say 3 words, and the LLM automatically infers what your intent is, what the average person intent is, and how you would like to have that personally customized for your tasks. And this is the foundation for what I think will eventually be very helpful agents. And it will make prompting feel less like a skill and more just like a conversation you're having with a friend or an assistant. Great, thank you so much.
So this is really an amazing session. Thank you. In that example you gave where the discharge instructions got it right except for one where it got it wrong, is that because wherever the language model searched on the internet, somewhere there was that wrong information? And if that is, or is that a problem just with the way that the system parses lots of information? And if it is finding wrong information, I assume that 50 sources would have had it right and one would have had it wrong. Why doesn't the model distinguish between something that is maybe not correct?
So briefly, I think I'll allude to something that Karan Singhal, the health AI lead at OpenAI, said yesterday at a session. And initially, when these models were trained, they were actually not trained on medical information. They were trained on general tasks, and they happened to be good at medical information because it was generalized into that. As they're working on this more and more and trying to fine-tune these models, they're giving it examples of medical tasks. A good example is HealthBench, which was released recently. And so they're overall trying to do a better job of fine-tuning in the future. That's how where this space is going to evolve and continue to evolve. Generally, hopefully, the way that it thinks about it is that if there are a million sources that say one thing and there's a couple of bad apples, those will get drowned out in the noise. And then they also try to filter try to avoid misinformation. But that is a really complex and challenging thing to do at scale, as you can imagine.
Yeah, I mean, that was essentially a hallucination, and we unfortunately didn't have time to get into hallucinations here, but there is fundamentally, at its core, the problem of, based off of the prompt that I gave it, in the embedding space and in the sort of the vector space, there is a strong association between what was just typed and the next word, which was swelling for some reason. It's kind of believable at a glance, right? And as sort of we have more correct label training sets for these new models to benchmark off of, they actually do get better and better. And in fact, I'm actually willing to bet quite a lot that so those slides are around like 6, 8 months old. If I type the exact same thing, I am almost certain that that thing is going to be gone now. It's going to be completely correct.
Does giving a better prompt help that?
I think that a lot of these things are limited to the base model. You can try, and when you do production prompts, when you're like making a prompt for a thing, people will try to do various things to stop it from doing those things. But the reality is eventually the base models are just going to get better and better and more aligned and accurate.
Mm-hmm. So that was an accuracy and recall-based thing, right? It was like, for this thing, what does the patient need to know? And there are a few different techniques that you can do. But like Shivam said, that is really like a foundational, like these are the problems with the building blocks kind of problem, and that continues to get better over time.
All right, why don't we thank one more time Dr. Vedak and Dr. Yao.